Hello, good evening, students. So last class we were discussing. Last class we were discussing MCQs. Okay. So related to solution chapters. So we'll continue with the same. So last class we have solved some 8 questions. Okay. So we'll continue with the same. So the next question, the law which indicates the relationship between solubility of a gas in a liquid and pressure is. So the options are Raoult's law, Henry's law, lowering of vapor pressure, and D. Van Hoff law. Yes. So the law which indicates the relationship between solubility of a gas in a liquid and pressure is. Yes.
Henry's law.
Yes, Jyoti, your answer is right. So it is B. Okay. So according to Henry's law, so what does Henry's law states? That a mass of a gas dissolved per unit volume. Okay. That is mass which is dissolved per unit volume is nothing but it is solubility. It is said to be solubility. So this solubility of a gas is directly proportional to the pressure of the gas at that temperature. So it is given as mass. So, mass, it is indicated by small m. So mass is directly proportional to pressure. So when you remove this proportionality sign, so you have to introduce a constant which is called as Henry's constant into P. Okay. So the answer is B. So B is the correct answer. So according to this law, the relationship between the solubility of a gas in a liquid and pressure is Henry's law. Okay. Now, so when you're talking about lowering of vapor pressure, so when you're talking about lowering of vapor pressure, this is not a law, it is a colligative property. Okay, so this is a colligative property and this is not a this is not a law, it is a colligative property. So this option is ruled out. Then Van Hoff's law. Okay, when you're talking about Van Hoff law, so in any reaction, if there is increase in temperature, so if there is increase in temperature, then the endothermic reaction takes place. So the rate also increases. So, okay, so in the Van Hoff factor, it talks about endothermic reaction. Okay, if the temperature increases, okay, what happens? The rate of the reaction also increases. So this is also not concerned with solubility. Here it is concerned with the rate. Okay, the temperature, as the temperature increases, the rate of the reaction also increases. So here it is nowhere concerned with solubility. So this is not concerned with solubility. Okay, so this option is also wrong. And Raoult's law, you know what is Raoult's law? So Raoult's law, the partial pressure, okay, is directly proportional to the mole fraction which is present in the solution. So this option is also ruled out. So B, okay, Henry's law. So it is the correct option. That is the law which indicates the relationship between the solubility of a gas in a liquid and pressure is Henry's law. So B is the correct answer. So we'll go for the next question. So among the following substances, the lowest vapor pressure is exerted by. Yes. So among the following substances, the lowest vapor pressure is exerted by. You can try. You can try to solve. Okay.
What?
You can also just try to answer the questions.
Okay. So here is the vapor pressure temperature.
Yes. So when we are talking about vapor pressure, okay, so we'll study about the concept of vapor pressure here first. So vapor pressure, when we are talking about vapor pressure, okay. So this vapor pressure, when you're talking about vapor pressure, so vapor pressure is inversely proportional to boiling point of the liquid. Okay, so vapor pressure is directly proportional to the boiling point of the liquid. So remember this. So as vapor pressure is inversely proportional to boiling point of the liquid, if liquid is higher, okay, if liquid has higher boiling point, now if liquid has higher boiling point, then it will have what will be the vapor pressure? It will be high or low. If the liquid has higher boiling point, what will happen to vapor pressure? Vapor pressure will be high or low.
Low.
What will happen to the vapor pressure? Then it will have what? It will have lower vapor pressure, right? Because it is inversely proportional. As it is inversely proportional, if liquid has higher boiling point, then this what vapor pressure will be lower. Okay, because it is inversely proportional. If boiling point is higher, then vapor pressure will be lower, or vice versa. Vice versa means what? If boiling point is low, then what will happen to vapor pressure? Vapor pressure will be more. Okay, so and vice versa. So remember this point. So vapor pressure is inversely proportional to the boiling point of the liquid. So if liquid has a higher boiling point, then it will have lower vapor pressure. Okay, and if a liquid has higher boiling point, then it will have lower vapor pressure, and vice versa. So when we are talking about this now, boiling point of a liquid. So boiling point of any liquid, okay, it depends on intermolecular forces. Okay, it depends on what? It depends on intermolecular forces. So boiling point of any liquid, it depends upon the intermolecular forces. That is the molecules of the liquid are tightly bonded with strong molecular forces. What do you mean by intermolecular forces? That the molecules, okay, the liquid, in the liquid there are molecules. So these molecules are tightly held, okay, they are tightly bonded with strong molecular forces, and therefore they are going to have what? They are going to have a higher boiling point. So this boiling point of any liquid, it directly depends on the intermolecular forces. Okay, what is intermolecular forces? That the molecules of the liquid are tightly bonded with strong molecular forces. Okay, so they are going to have, so if they are bonded with strong molecular forces, then they are going to have high boiling point. So in this case, mercury, you know, mercury, okay, mercury will have what? Mercury will have very strong intermolecular forces. Okay, mercury will have very high intermolecular forces. Then magnesium, okay, so it will have very high molecular, it depends on the intermolecular forces. Then when you are talking, so this what? Water, alcohol and ether. Now, so what will happen now? Magnesium is a metal. Okay, magnesium is a metal, and whenever you are talking about them, so in metal, so whenever you are talking about metals, okay, whenever you are talking about metal, the mercury metal, okay, so the what is that? The forces which are acting between the metals. So whenever you have metal metal interaction, okay, the metal metal, when they are so whenever the forces which are acting between the metal metal, so they are very strong. So whenever you have high boiling point, what will happen to vapor pressure? Vapor pressure will be low. So here in this case, what? Mercury will have higher, it will have higher boiling point. Okay, and other three will have lower boiling point. Okay, then your mercury. Okay, so mercury will be having, so mercury will show high boiling point. So because of that, it will show lowest vapor pressure. So mercury is the answer. So which is the answer? So mercury is the correct answer. So as mercury will show higher vapor pressure, that is higher boiling point, it will exert lower vapor pressure. So the answer is D. Okay, the answer is D. Understood? So we'll go for the next MCQ. So partial pressure, okay, partial pressure of a solution component is directly proportional to its mole fraction. So this is known as, So partial pressure of a solution component is directly proportional to its mole fraction. So this is which law?
Rawls law.
Which law?
Rawls law.
This is which law? Yes, it is Rawls law. Yes, it is Rawls law. Okay, what does Rawls law states? Rawls law states that the partial pressure of a solution component is directly proportional to its mole fraction. Okay, that is partial pressure. It is PA. Okay, is directly proportional to its mole fraction A. Okay, and if there is a binary solution B, so it is for XB. Okay, so for binary solutions, so these are the two binary solutions, A and B. For binary solutions, A and B. So partial pressure of a solution component is directly proportional to its mole fraction. So this is B. The option is B. Okay. So B is the correct answer. Then next question. 3 moles of P and 2 moles of Q are mixed. Okay. What will be their total vapor pressure in the solution if their partial vapor pressures are 80 and 60 torr respectively? So this is a problem. Okay, so 2 moles of P and 2 moles are Q, they are mixed. Then what will be the total vapor pressure in the solution if their partial vapor pressures are 80 and 60 torr respectively? Okay, then so how to solve this? Now we have to write the what first you have to write what is given. So what are the given entities? Okay, so given so first is what? Number of moles. So number of moles of P is how much? So it is 3. Number of moles of P is 3. Then number of moles of Q is how much? It is 2 moles. Okay, so these two are written. Then next is what? Then their partial vapor pressures are given, right? Partial vapor pressures are given. So partial vapor pressure of P. Okay, partial vapor pressure is denoted by naught, P naught P is how much? It is 80. And partial vapor pressure of Q is how much? It is 60. Now what they have asked? They have asked the total pressure. Okay, they have asked the total pressure. Okay, you don't know what is the total vapor pressure. So we'll write it as this. Okay. So whenever you are representing this knot represents the partial pressures. Okay, partial pressures or of pure components. So this is P naught. Okay. So now how to find the total pressure? So how to find the total pressure? So total pressure, that is PT, is what? It is sum of individuals. So that is P plus PQ. Okay. So so how it is given? So partial pressure. Okay. So the total pressure exerted, total vapor pressure is equals to sum of the partial vapor pressures. So PP is nothing but further substituting with it P naught P into XP. So this is according to the Rawls law. Okay, plus P naught Q into XQ. So now substitute it. What is P naught P? P naught P is what? It is 80 into what is XP? Okay, XP is what? You have to find out the number of moles now. Now we have to find out the number of moles of P and number of moles of mole fraction of Q. So first we'll find XP. So what is XP? XP is number of moles of P, okay, by, so that is 3 divided by 3 plus 2, right? So this is a number of moles of component A divided by sum of the component of A plus B. You know how to find the mole fraction. So so number of moles of component P divided by P plus Q. Okay, so it is 3 divided by, so this is 3 by 5. So this is of what? This is of P. Now we'll find for T. So that is XQ xq is equals to, so for q, it will be number of components of q divided by 2 plus p plus q. So that is 3 plus 2. So this will be 2 divided by 5. Okay, now we'll further now we'll add this mole fraction here. Okay, we'll add this mole fraction here. So further what we'll get? So 80 into xp is what? 3 by 5 plus p naught q is what? P naught q is 60 into mole fraction of q is what? 2 by 5. Okay, now further simplify this. 5 ones are, this will be 12. Okay, this will be 5 ones are, this will be 5 ones are, this will be 6. So you will get what? Just simplify and see what you're getting the answer. So this will be 16 into 3 will be 48 plus 12 twos are 24. So after what you're getting? 4, 12, 4, 5, 6, 7. Okay, so it is 72 torr. Yes, it so what so it is 72 torr. Are you getting the answer? 72 torr.
Yes, ma'am.
So it is 72 torr. Okay, so answer is 72 torr. Understood? Yes, understood. Okay, so like this, you have to find out. Okay, just simplify whatever is the given entities, write the given entities, and then you have to solve the particular question. Okay, so this is the way you can solve this. So next, we'll go for the next question. So here, which is the option? So option is C, 72 torr. Okay, 72 torr. Next, so which of the following solutions show positive deviation from Rawls law? A, acetone plus aniline. B, acetone plus ethanol. C, water plus nitric acid. D, chloroform plus benzene. Okay, so now before going for positive deviation, you need to know how it is. Okay, so it comes from what? It comes from Rawls law. So Rawls law. So in Rawls law, there are two type of solutions. So that is ideal solution and non-ideal solution. What do you mean by ideal solution? Ideal solutions are those which obeys Rawls law, and non-ideal solutions are those which do not obey Rawls law. Now in non-ideal solution, they are further classified into, okay, that is what they are classified as positive deviation and negative deviation. Now positive deviation is what? In positive deviation, your solute solvent interaction is, okay, solute interaction. So in positive deviation, your solute interaction, solvent interaction is stronger as compared to the solute interaction. Okay, so when you're talking about positive deviation, the solute interaction, that is AA transaction, AA interaction, or AA interaction means solute interaction, or your solvent interaction is okay, solvent interaction is more stronger as compared to that of the solute solvent interaction. So that is AABB is more stronger than AB. So this is about positive deviation. Okay, what do you mean by positive deviation? That the solute interaction or the solvent interaction is stronger as compared to that of solute stronger interaction. So that is AABB, okay, is greater than AB interactions. Then when you're talking about negative deviation, what do you mean by negative deviation? That your solute, that is solute interaction, solvent interaction is weaker. So in this case, that is AA interaction, BB interaction is weaker than your AB interaction. Okay, so here it is weaker in negative deviation. So here it is stronger. So this is what is positive deviation and what is negative deviation. So based on this, so the answer here is B. Okay, acetone and ethanol. So why it is acetone and ethanol? Acetone. Okay, what is the structure of acetone? CH3, C double bond O, CH3, and ethanol is CH3, CH2, OH. Okay, so in this acetone interaction and ethanol interaction is stronger as compared to that of acetone ethanol interaction, because here hydrogen bonding is not strong. Okay, hydrogen bonding is not strong. So in this case, what is happening? So because, so here the acetone interaction, okay, acetone and acetone interaction is more stronger, and ethanol interaction is more stronger as compared to that of acetone ethanol interaction, because in acetone and ethanol to be like for it to be in interaction, the hydrogen bonding should be stronger, but it is not so. Because of this, acetone and ethanol interaction is what it is weaker. Okay, so it is weaker. So in this case, acetone ethanol, so it shows a positive deviation, because in this case solute interaction and solvent interaction is more as compared to that of solute solvent interaction. Okay, now when you're talking about the next other options, that is acetone and aniline. So acetone and aniline, it shows negative deviation. So this is also ruled out. Okay, this is a wrong option. Then when you are talking about water and nitric acid, so this is also an example for negative deviation. So this is also ruled out. So this option is also ruled out. Then chloroform benzene. So this is also a negative deviation. Okay, so you need to remember what is ideal solutions, what are non-ideal solutions, and what are in non-ideal solutions. You need to know what is positive deviation and what is negative deviation. Positive deviation means what? In that solute interaction, solvent interaction is stronger as compared to that of solute solvent interaction. In case of negative deviation, solute solvent interaction, okay, solute interaction and solvent interaction is weaker as compared to that of solute solvent interaction. So based on that, so acetone and ethanol, okay, so this will show the positive deviation based on the Rawls law. So B is the correct answer. So we'll go for the next one. So the system that forms maximum boiling azeotrope is, okay, the system that forms maximum boiling azeotrope is. Now, what do you mean by azeotropes? What do you mean by azeotropes? So azeotropes are, okay, azeotropes. So azeotropes, they are type of non-ideal solutions. Okay, so so first point, it is a type of non-ideal solution. Then it has maximum, they are called as maximum boiling azeotrope. Okay, they are called as maximum boiling azeotrope. Okay, they are called as what? Maximum boiling azeotrope. Now maximum boiling azeotrope, and they show negative deviation. So this azeotrope, they show negative deviation. So the system that form maximum boiling azeotrope is, so these are some of the given examples. So below in this example, you have to tell which will show the negative deviation. First one, acetone and chloroform. So it is an example for non-ideal solution and negative deviation. Okay, so so this is, yeah, okay, so A is the answer, that is acetone. So acetone and chloroform, they are non-ideal solutions and they show negative deviation, and they show maximum boiling azeotrope. They are maximum boiling azeotrope. Then the second one, ethanol and acetone, they show positive deviation. Okay, this is an example of positive deviation. You have just discussed what is negative deviation and what is positive deviation in the last slide. So so ethanol and acetone, they show positive deviation. Thus, when they have positive deviation, means they have minimum boiling azeotrope. Okay, When you have positive deviation, means they are minimum boiling azeotrope. They are called as minimum boiling azeotrope. So this is also ruled out. Then next one, N-hexane and N-heptane. So N-hexane and N-heptane, they are ideal solutions. Okay, ideal solutions. So maximum boiling azeotropes are what? They follow non-ideal solutions, and they are called as, they show maximum boiling azeotrope and they show negative deviation. Now N-hexane and N-heptane, they follow Raoult's law. Raoult's law means they are called as ideal solution. So if they are ideal solution, they do not form azeotropes. If they are okay, ideal, if they are ideal solution, then they do not form azeotropes. They do not form azeotropes. Okay, so this is also ruled out. Then next example, that is carbon disulfide acetone. Okay, that is CS2, CS2 plus acetone. So this also shows what? This shows positive deviation. This shows positive deviation. If they are showing positive deviation, means they will show minimum boiling azeotrope. Okay, so they are example of minimum boiling azeotrope. So this is also wrong. So our answer is what? A, that is acetone and chloroform. Acetone and chloroform. A is the correct answer. Understood? Okay. Others, did you understand?
Yes, ma'am.
Okay, so we'll go further. Okay, we'll go with the next question.
Oh, fine.
A plant cell shrinks when it is kept in a when it is kept in a. So there are four options. A, hypotonic
Hi
solution.
guys. The question that we
Okay,
are solving
hypotonic
today is
solution. Then B is hypertonic solution. C is isotonic solution. And D is pure water. Okay, so a plant cell, when it is kept in a, so in what, if it is kept, the plant cell shrinks. Okay, now plant cell. So assume a plant cell. So assume this is a plant cell. Now this plant cell, when it is kept, okay, so this plant cell, when it is kept, so this plant cell, when it is kept, okay, so what will happen? So this plant cell, so this is plant cell. Okay, so now when it is kept in a this, okay, so assume that it is kept. Okay, so there is, so it plant cell, what it consists of? It consists of solvent molecule. It consists of what? It consists of solvent molecules. It consists of solvent molecules. Okay, and this solvent molecules will what happen? They will be moving outside. So this solvent molecules will move outside. So the whatever the this is there. Okay, solvent molecules are present inside. Okay, solvent molecules means what? Water. So this water will start, what will happen? It will, so the amount of water which is there, so it will start flowing. So you know what is osmosis, right? What is osmosis? So it takes place from the higher concentration, okay, to lower concentration. So it flows so through a semi-permeable membrane. So here what happens? So water, that is the solvent molecule, starts to flow when the from the plant cell, the solvent molecule, it starts coming or it starts moving outside the outside. Okay, if it starts moving outside, what will happen? What will happen if it starts moving outside? So this cell will shrink. Okay, the cell will shrink then. Okay, the cell will start to shrink. Now so if the cell starts to shrink, then what will happen? So less amount of water will be there, right? Because it will happen when the cell will start getting shrink, when less amount of water is present. Okay, when the less amount of water is present, then the cell will start to shrink, right? Now, if less amount of water is present, that is solvent is present, then what will happen to solute? So it will be more amount of solute is present, that is more amount of solute, right? If solvent is less, if the solvent is less, what will happen to solvent? Yes, if solvent is, if the amount of solvent is less, then what will happen to solute? Solute will be more. So more amount of solute is present. Okay. So if more amount of solute is present, then concentration of solution will be more. So concentration of solution is more, right? Now you know that osmotic pressure, right? Osmotic pressure is directly proportional to what? It is directly proportional to concentration. Now, if osmotic pressure is higher, then it is what? It is hypertonic solution. So this is what? This is a hypertonic solution. Now, hypertonic solution. So this is what osmotic pressure is. So osmotic pressure is higher here. Osmotic pressure is higher. So if it is higher, means it is called as what? It is called as hypertonic solution. It is called as hypertonic solution, right? So from the plant, what will happen? The solvent molecule will start moving outside. So once the solvent molecules start to move outside, what will happen to cell? The cell will shrink. So as the cell will shrink, what will happen to amount of solvent molecule? There will be less amount of solvent molecule. If the amount of solvent molecule is less, what will happen to solute? There will be more amount of solute. If amount of solute is more, then what will happen to concentration? Concentration of solution will be also more. You know that osmotic pressure is directly proportional to the concentration. So as the concentration increases, what will happen to osmotic pressure? Osmotic pressure will be higher. Osmotic pressure is higher, means it is called as hypertonic solution. Okay. Now this is inside the cell. So this is about inside the cell. Now when we are talking about outside the cell, okay, what is happening outside the cell? So here, as the water is start flowing, okay. So what will happen here? The amount of water, okay. Now here the amount of water will be more. So the amount of water will be more. Now what will happen to the amount of solute? So amount of solute will be less, right? Amount of solute is less. What will happen to the concentration? Concentration also will be less. If concentration is less, then it is called as hypotonic solution. Then it is called as hypotonic solution. So always you know that this is what always in osmotic, what will happen? It goes from a higher concentration to lower concentration through a semi-permeable membrane, right? So the answer is hypertonic solution. So till when it will go? Till the solution which is inside, okay, so the inside the this and outside, it will become in equilibrium. Till then the solvent molecule will start flowing. Okay, till it comes in equilibrium, till both are equal. Okay, so it starts flowing. So this is called as hypertonic solution. So the answer is hypertonic solution. I hope you have understood. Yes. Okay. Fine. So we'll go for the next question. So the relative lowering in vapor pressure is proportional to the ratio of number of. Okay. Now, what is relative lowering of vapor pressure? So relative lowering of vapor pressure. So relative lowering of vapor pressure. So it is given as what? Lowering of vapor pressure is P naught minus P divided by P naught. So relative lowering of vapor pressure is directly proportional to X2, that is mole fraction. Okay, it is directly proportional to ratio of number of mole fraction. Okay, so that is X2. Now here, what is P naught? P naught is vapor pressure of pure component. Okay, P naught is always the vapor pressure of pure component, and P is what? P is vapor pressure of solution. Okay, this P is nothing but it is the vapor pressure of solution. What is X2? X2 is what? It is mole fraction of solute. Okay, it is the mole fraction of solute. Then, so X2, how X2 is given? X2 is N2 divided by N1 plus N2, right? What is N1? N1 is number of moles of solute. Number of moles of solute, okay? And N2 is what? N2 is number of moles of, sorry, N1 is number of moles of solvent, and N2 is number of moles of solute. Okay, so N1 is number of moles of solvent and N2 is number of moles of solvent. So X2 is what? It is mole fraction. Okay, and mole fraction is calculated as number of moles of solvent. Okay, number of moles of solute divided by the total number of moles in solvent and solute. Okay, that is in the solution. So we'll just see now. So according to this, so that is what did we say? That is relative lowering of pressure, vapor pressure is directly proportional to mole fraction. Mole fraction is what? Number of moles of solute divided by number of moles of solute plus solvent. So when you talk about solute plus solvent, is nothing but your solution. It is nothing but your solution. Okay, so which is the correct option? So relative lowering of vapor pressure is directly proportional to mole fraction. Mole fraction is nothing but it is the number of moles of solute divided by total number of moles of solute plus solvent. Solute and solvent is nothing but solution. Now, which is the correct option among the following? Yes, it is C. C is the correct answer. That is solute molecules to the total number of molecules in solution. So C is the correct answer. So you can see, right? So this is, so according to the formula, okay, so relative lowering of vapor pressure is directly proportional to the mole fraction. Mole fraction is nothing but number of moles of solute divided by the total number of moles of solute plus solvent. Solute plus solvent is nothing but the solution. So C is the correct option, right? So we'll go for the next question. A solution containing 10.2 grams of glycerine per liter is isotonic with 2% solution of glucose. What is the molecular mass of glycerine? Okay. So a solution, it contains what? It contains 10.2 grams of glycerine per liter and it is isotonic. Okay, what do you mean by isotonic? Isotonic solutions. Isotonic solution means what? The concentration of one solution is equal to the concentration of two. That is C1 is equals to C2, right? That is pi1 is equals to pi2. That is C1 RT is equals to C2 RT. So RT, they are common, so they get cancelled up. So therefore C1 is equals to C2. So therefore I can say that concentration of glucose will be equal to concentration of glycerine, right? If they are isotonic, isotonic means both the concentrations are same. So that means C1 is equals to C2. So the concentration of glucose is equals to concentration of glycerine, right? Now concentration is given as number of moles of glucose divided by volume of glucose. Okay. Right. So you can express like this. So I'll just write it here. So what is concentration? Concentration of glucose equals to concentration of glycerine. Okay. Now concentration is nothing but number of moles of glucose upon volume of glucose is equals to number of moles of glycerine equals to upon volume of glycerin, right? So we'll just substitute this now. Till here it is clear. Okay, so from here. Now, till here it is clear. Okay, so we'll go further. So further we'll just substitute. So here number of moles. Okay, number of moles of glycerine. It is what? It is 10.2 grams. 10.2 grams. Okay, so 10.2 grams divided by. So we don't know the molecular weight. So we don't know the molecular weight. So we'll keep it as X. So divided by the volume. So we don't know the volume. So volume will be what? It will be 1. It will be equal to 1. So it will be equal to 1. So that is equals to then 2% solution of glucose. Okay, this is for glycerine. So this is for glycerine. Now we'll write for glucose. So for glucose, 2% means 2 grams of glucose in 100 ml. Okay, so it will be 2 gram divided by what is the molecular weight of glucose? It is 180 divided by the volume is how much? It is in 100. Okay, 100 ml. So now this you have to multiply it by 1000 because volume you are multiplying it by 1000, right? So this is in liters. So this is in liters. So so what you get? So you have to find out the molecular weight of glycerine. So we have asked the molecular weight of glycerine. So after substituting this, okay, you get molecular weight is equals to, so this will be 10.2, okay, 10.2, and this will be into 180, okay, 180 divided by 20. So after further substituting this, you get what? You get, just see what you are getting the answer after substituting this. So it will be 91.8 grams. Okay, so the answer A will be correct one. So correct answer is yes. Okay. So A is the correct answer. So A is the correct answer. 91.8. So just whatever is the given entities, you have to write you have to just substitute in the formula and you will get the correct answer. Okay. So next is what weight of glycerol should be added to 600 grams of water in order to lower its freezing point by 10 degree Celsius. So here we are going to use the freezing. Okay. So here what all are the given entities will write. So given, so what we have to find out, what weight of glycerol should be added. Okay. So weight of the solute we don't know. Okay, so weight of the solute we don't know. So the first is what? Weight of the glycerol. Glycerol is nothing but solute. So weight of the solute we don't know. So it is WB. And water. Okay. So then 100 grams of water. So this is weight of the solvent. So that is WA is equals to how much? It is 600 grams. Okay. Then to lower its freezing point. Freezing point is delta TF. So delta TF is what? 10 degrees Celsius. So this is freezing point, low relative freezing point. Okay, so that is TF is equals to 10 degrees Celsius. Then you know the molecular weight, okay, of glycerol. So the molecular weight of glycerol is 92 grams. So it is known. So glycerol, if you calculate the molecular weight, it comes to 92 grams. Now, what is the formula of TF? Okay, and that is a freezing point. So TF is equals to KF into M. Okay, KF into M. So that is equals to 10. So 10 degrees. So TF is what? 10 degree is equals to, okay. So KF is 1.8. So it is 1.86 into WB. WB by what is the molecular weight? It is 92 into 1000 divided by WA. What is WA? It is 600. So 600, this will get cancelled. Okay. Then what you do? So next step, so 10 into, so 1.86 into 10, it will become 18.6. Right. So this will go down. Just a second. So after 10, so this will get cancelled to this. So 10, next step 10 into, so this 92 which is divided, it will come and get multiplied here into 92 into the 6. Okay, the 6 also go, if you take on the other side, it will be multiplied, then divided by this 1.86. If you multiply it by 10, it will be 18.6. So this equals to WB. This will be equal to WB. Now solve and see what is the answer.
Option
Yes.
B.
So it comes to around 296.7 grams. Okay, so it is B. Okay, it is B. So I hope you have understood. Yes. Everybody has understood. Yes, others. Okay, fine. Then okay then. Okay, so it's already time up. So we'll stop for today and we'll continue in the next class. Meanwhile, I'll just whoever are present, just drop your names in the chat box.
Sprinkling of
Okay. Okay, fine. Yes, you can leave. Others can leave. Yes, thank you.